Okay, this is a quick update on the basic interpreter progress. It's now got floating point, and unfortunately, because of the huge variety of basic language variants out there, I found I couldn't get one interpreter to handle them all. So I've ended up with 3 variants. One is similar to the one we saw before, which was based on Tiny Basic, which handles 16-bit integer values. I then did one that handled 32-bit integers, and this third one handles 32-bit floating point. They all share a common core, so the way you drive them is exactly the same. The floating point version has a lot more functions than the other two. It's mainly due to the trigonometric functions, sine, cos and tan, etc. And the interactive mode is now started up a bit, so I can just print 4, say, and the answer comes out straight away. And there's the random function, which prints a number between 0 and 1. And the random function on the other two, you give it a parameter, and it gives an integer value between 0 and that value. So there are a few others. Absolute, which gives you the positive absolute value of a number. The print item list has been tidied up. Commas now separate the numbers by tabs or zones, whereas semicolons just print the normal spaces which occur on numbers. All numbers have one trailing space, and positive numbers have one leading space, whereas strings don't have any. So if we say EF and GH, they come out together with no separator. There's a comma, prints them in 2 different zones. Right, the batch mode works by either loading a source file from magtape or paper tape, which is what we saw last time. Do a help. There's the load P and load M commands. And the other way of entering programs is to use what I call a RAM file, where if you use line numbers on a basic statement like that, it will be stored into a file in RAM. And this offers a very crude line editing function. So if I put line 5, print 5, and then list the RAM file, they're sorted in numerical order. So I can add a line 11, I've got the clear screen command, this is a basic command, so this is obeyed interactively, but it achieves the same thing. Now we can see the RAM file contents. So this is equivalent to having the source on a media file, on paper tape or mag tape, and in all cases you have to load it first before you can run it. And the load does the pre-processing, which I spoke about before, which tokenizes the file. So for the RAM file you just say load, and you can now list the tokenized file, and this is what we run. Del deletes the RAM file, so we'll put in a for loop. N equals 1 to 5, 20 print n squared, 30 next n. The n is optional, but if you do put it, it has to match. Load, and then run. The floating point display shows that we're not quite exact, but we can use the integer function to fix that. So if we retype line 20 and say print integer and the expression n squared, we add 0.5, that should round it. Reload and run. Again, let's put line 1 clear screen, load, run. Now it's a cleaner display. The variables, you can say let a equal 5 in interactive mode, and the value is persistent. So if I say print A, you get the value of A. None of the variables get cleared automatically, but you can use a clear command at the beginning of your program if you want to start with a clean slate. And this allows you to pass variables from one program into another. So let's do another one. 10, do a clear screen, 20 for D equals 0 to 180. It supports the step option. So we'll go step 15. 30 will print D and sine. All the trig functions take radians, so we need to convert this to radians. So what I'll do is I'll say D times some factor, which I'll sort out in a minute. 40 next, and we can put these factors in outside the program. So I can just say let pi, say p for pi, equal 3.14159, I think. And let the factor, which is 2 pi over 360, 2 times p divided by 360. So those variables would be persistent and they'll be picked up by the program. So we need to load and process the source. I can list it just to make sure. And in theory, let's do a clear screen. 5, clear screen, load, and run. And you can see with the sine function, sine 0 is 0, sine 90 is 1, and 180, the function goes back to 0. Here's damn it. If I edit line 20 and say 4D equals 180 to 360, step 15, load, run, and you see the function goes negative, -1, back to 0. Right, I'll just do one more, clear the RAM file. Let's have a subroutine. So we have line 100, we'll say f equals 0. You don't need the let inside a program, although we did in interactive mode. 110 for count equals 1 to n. You have to guess what this does. 120 f equals f plus c. 130 next, and 140 return. Check that, that's a subroutine. Then we'll have line 5, clear screen, 10, input, and we can put a prompt number question mark comma n, and that will prompt with the variable n. 20 can say go sub 100. That will obey the subroutine with the value of n, and then when it comes back 30, we can print, we can say factorial, if you haven't already guessed, semicolon n, semicolon is, semicolon f. And 40, we can go back to 10 and ask for another input. Okay, we'll load and process that. And run. There's our prompt. We'll do 3. That's going to add 1, 2 and 3 together. And hopefully that's about right. 6. 5 will do 1 to 5. 10. And the inputs, as you type in numbers, a single escape clears the line if you want to quickly retype it, and if you do another escape it drops out. Okay, I think that's about it. The major thing missing at the moment is string variables, so I might put something simple in there. I don't want to go too complicated with this, but it is a fun programming language to play with. I can certainly recall the appeal of it when it first came out, a lot simpler than machine code. All the 3 variants are available from the website. The links are in the description below. So thanks for watching.